Thanks, Tal. Evening, everyone. As Tal has said, my name is Phatha, short for Patisizwe, from Casme, and I'm one of the maths facilitators at Casme. I'm going to share my, but as Tal said, we'll share the slides with you. You may find that the slides may have gaps here and there, so feel free to fill in those gaps. The intention is to actually focus on grade 10 trigonometry. And within the grade 10 trigonometry, the assumption is people have done trig. But if you haven't done the trig, no, you don't have to worry. And if you've done it, you'll find that probably the activities we'll do here will enhance the knowledge you already have. Well, what I would want you to do, or beg you to do before I start presenting my slides, is whatever we do and whatever I say, please think critically about it, and you're welcome, as Tyler said, to sort of interrogate it if possible. There will be some patterns that might be emerging. Well, it's fine if you make conjectures, because I'm not going to be dealing with any proofs, but I will always allow you to think deeper about things. I'm going to start now my slideshow. I hope everyone can see what is on my slide. Can you all see the slide?
Thanks, Phatha, we can see it.
Okay. All right. I've tried to be as detailed as possible, but if there is something that needs me to explain and write, I will try and use the whiteboard, but I'm not good at using the whiteboard. And I'm so happy to see people even from Gauteng. Most of the activities that I will be taking you through are taken from previous written papers. And I think most of them come from a Gauteng paper. But anyway, it's fine. If you've done them, you'll find that probably they are done here in other ways that are different. We go beyond one way of doing them. All right. I don't know what's wrong with my slideshow. I'm trying to go to the next slide. All right. The first thing that I want to take you through is the outline of the presentation. Well, I will talk briefly about the history of trigonometry. Why do I do that? It's because for the first time, the topic is formalized in grade 10. I will also look at some helpful pre-knowledge. I want you to know that when you do any topic at any grade for the first time, there is knowledge that you already possess that becomes very useful for understanding the topic. I will also just take you through a few applications of whatever we've learned. Then I will actually take you through the real trig ratios using right-angled triangles, do a bit of activities there, take you through the trig ratios from Cartesian plane, also do a bit of activities from that section. Right. Let's get to the brief history. Trig is one of the oldest fields of mathematics. It was, for instance, you'll find that it emerged during the 3rd century before even Christ was born, from applications of geometry in astronomical studies. It has wide applications in education, engineering, aviation, astronomy, art, navigation, economics. I don't know what I can mention. When specifically say in education, besides applications in maths, you'll find that for you to understand science when you do vectors, you have to know your trigonometry. Well, what's interesting about this field of mathematics is that it can be traced back to Africa, ancient Egypt. And that made me proud as an African that, oh, wow, this originates from Africa. I just wanted to show you, here's a picture of an astronomer, somebody who's studying the stars. Well, you'll find that the study of stars goes a long way in science. It might not make sense for us at this level, but later on you'll find that it's one of the very important studies that are done in mathematics. Here's an engineer, or let's call him a surveyor. And that is holding in front of him is called a theodolite. You can scroll or you can Google what a theodolite is. You'll find that they'll show you images and tell you how it works. Okay, what knowledge will help us understand this better? One of them is you must know your numbers. You must know your numbers. You still have to know that 1 + 2 is 3. Specifically, we are dealing with ratios in trigonometry. So you have to know how to work with your fractions. And quite often some of the fractions that you work with are irrational. So you still have to know how to work with your sets. Of course, you've got to know algebraic manipulations. I will always draw your attention to these manipulations as you do them. For instance, how you multiply a monomial by a binomial, the formula, and all those things. How do you solve equations? That knowledge comes very important. Linear graphs. Linear graphs, I like doing Trig and relating it to linear graphs because in linear graphs already we've done gradient. And one of the trig ratios that we'll be discussing today is nothing but gradient or inclination. With your triangles, know some properties of triangles, know about similar triangles, and also know the theorem of Pythagoras. Well, I'll keep flagging this as we go across, as you go through the slides. One general application of trigonometry is to determine height of objects. For instance, as you can see in the picture there, if you want to know the height of the building, of that building structure, we don't really have to try and climb along on the side of the building and do the tape. But using trig, if we know our distance from the building and we know the inclination from the bottom to the height to the top of the building, we can always determine the height of the building. Finding distances. Well, I've just chosen this one. Like for instance, if you are at the beach and you can see an island in the sea there, you don't have to walk there or swim there in order for you to know how far the island is. Using trigonometry, you can calculate the distance of the island from the coastline. We will do this problem in the end. And what I like about this is then it shows us how mathematics is used to find distances of how far the sun is from the earth without really going to the sun. We can use trig and determine that the distance of the sun from the earth, or even the stars. That's why it's used in astronomy. Right. As you can see, I said the knowledge of triangles is important here. You can see that now here you've got this person moved from point A to point C and knows the distance between A and C, and then is joined the distances between the points A and C to the distance on the island. And you can see that what you've got there are triangles. What's important here is, I want to say, in this diagram, your BD is perpendicular to AC. When I say it's perpendicular, what does it mean? It means that the angle formed, if you measure the angle CBD or you measure the angle ABD, its measurement will be 90 degrees. Right, I just want to take you through some important terminology that we use around triangles. In this triangle, if you look, for instance, at triangle ABD, this triangle, this is the triangle ABD, which is a right-angled triangle. I'm going to try now and sort of assign names to the sides. Now, the names are assigned relative to the angle. Well, the side AD, which does not form the right angle, but is opposite to the right angle, we call that one the hypotenuse. The side DB, this side DB is not one of the arms of the side of the angle A. So we say DB is opposite the angle A. So when we speak about the opposite side, the side that is opposite to an angle will not be part of the arms of that angle. And then AB is adjacent to angle A. Now the adjacent side is one of the arms of the angle, which is not the hypotenuse. It is one of the arms of the angle that is not the hypotenuse. That is very important. Now, if you go to another triangle in the diagram, the triangle CBD, I'm sure now you can guess which side is the hypotenuse. Which side is the hypotenuse? DC, because our right angle is here at B. So the side that is opposite the right angle, which is not arm of the right angle, we call it the hypotenuse. Generally, it is the longest side in your triangle. Now, I want you to know that it doesn't matter how your triangle is orientated. As long as you can identify your right angle, the side opposite the right angle will be your hypotenuse. Which side will be the opposite side to angle C? Because you know angle C is 50 degrees. The side opposite angle C is DP. DP, you can see that DP is not an arm of angle C. So we said the opposite side will always be not part of the arms of the angle that we are speaking about. And then BC is adjacent to angle C. Adjacent, which means it's one of the arms that form angle C, but it is not the hypotenuse. Now, I'm going to start now defining the trig ratios to you using the right-angled triangle. The first one that I want to introduce is the tangent, which is briefly abbreviated as tan, T-A-N. Tan is short for the tangent. Now, for any angle x in a triangle, if in a triangle there's an angle x, the tangent of that angle x will be the ratio of the length of the opposite side to the length of the adjacent side. So which means whenever you see the angle x, if you want to find the tangent of that angle x, you must first determine which side is opposite and which side is adjacent. And then if you take the ratio of the opposite side to the adjacent side, that ratio we will call the tangent ratio. The next one that I'm going to be introducing is the sine. And short for the sine, we use sin, S-I-N. For any angle x, the ratio that we refer to as the sine of the angle x is given by the length of the opposite side divided by the length of the hypotenuse. And the cosine, which is the short for that is cos, is the ratio of the length of the adjacent side to the length of the hypotenuse. Well, these I would advise learners to always write them on a piece of paper, hang them somewhere next to your bed so that you see them every day and they become your friends and you know them as you know other people that you live around with. If you see them every day, every night before you sleep, they become part of you. Right, let's look at this example here. In the example, I've got triangles. Triangle ABC and triangle ADF. These two triangles, they share an angle. The angle that they share, I've called it alpha. Now, if I want to find the tangent of alpha, I will look at which side is opposite alpha. BC is opposite alpha, and which one is adjacent alpha in the smaller triangle? It will be AB. So the tan of alpha in this one is either BC over AB. Or if I'm using the bigger triangle, it will be DF over AD. And now what I want you to note here is that if you look at the two triangles, these two triangles are similar. And I'm sure in grade 9, you learned that whenever you've got similar triangles, the ratio of corresponding sides, the ratios of the corresponding sides are proportional. As you can see that CB over AD over AB is equal to DF over AD. And that gives us the tangent of the angle alpha. Now, the sine. Can you still remember how we find the sine? We must first find now which side is the hypotenuse. If you look at the small triangle, the hypotenuse is opposite the right angle, which is AC. If you look at the big one, the hypotenuse is AF. So now we define the sine. We said the sine is given by the opposite side. So here, this is the opposite side. This is our angle alpha. The opposite side is BC over our hypotenuse, which is AC. Or else, if we're looking at the bigger triangle, the opposite side is DF and the hypotenuse is AF. The third one is the cosine, which we write as cos. Now, how to find cos? Now, for the cos, we use adjacent and the hypotenuse. Now, if you look at our angle alpha, which side is adjacent? AB. And which side is the hypotenuse? Already we've said hypotenuse is AC. So now for the cosine of alpha, it's either BC over AC, or it is equal to AD over AF divided by AF. So we can see that now, given any triangle, we can always determine the tangent, the sine, and the cosine. Here's the first activity. Now here we are given a figure. And in the figure, how many triangles can you see? Now we've got triangle KNL. Now if you look at triangle KNL, is it a right angle triangle? No, it is not. But if you look at triangle KNM, KNM is a right angled triangle. And if you look again at triangle NLM, it is also a right angled triangle. I'm sorry, I did not mark here that this right angle. Oh, this square moved. that I don't know why it moved from where it was. I wanted to show that this right angle triangle. Right. Now, which means here, if you want to find the sine of alpha, would it be correct if I say it's NL, which is opposite, over KN? No, we said the hypotenuse should always be opposite the right angled. We should always be opposite the right angle. So if you want to find the sine of alpha, now we should use a right angle triangle NKM. NKM. So what would be the sine of alpha? The sine of alpha would be the opposite side, which is NM, over the hypotenuse. What is our hypotenuse? It is Kn. So as you can see here, I've got this, I've redrawn from here, and I can say that if you want the sign of alpha, the sign of alpha is Mn over Kn, where it means if we're given shapes, in any given shape, we must always identify right-angled triangles. And then we only use right-angled triangles to find our trig ratios. So in this case, the sign of alpha is Mn over Kn. The next question wanted us to find the tangent. Tangent of alpha. Here's alpha. To find tangent, we use the opposite side and divide by the adjacent side. So you can see that now tan alpha is equal to Mn over Km. Now one cos beta. Now for beta, for the angle beta, we are going to use this triangle, the triangle NLM. As you can see that now, the adjacent side here is LM. And what is the hypotenuse? The hypotenuse is LN. So to find cosine of beta, we use adjacent side over the hypotenuse, which is LN. The tangent of beta. Again, the tangent of beta now, because we are looking at this smaller triangle, our opposite is still NM or MN, but our adjacent side is LM. So tangent will always be the opposite side divided by the adjacent side. So these are the solutions for the first activity. Now here's the second activity. Now they say here, use the length of the sides in the figure below to write down the following ratios. It's fine, you can use the name of the sides, like you could use PR or you could use PQ. But in the end, you need to use the numbers that are given there now. Instead of saying PR over something, you write 5 over some other number. Now, again, in the triangle, we are shown that this is the right angle. Now, so which side is the hypotenuse? We said the hypotenuse is always opposite the right angle. So it is QR. Which side is the opposite to our angle theta? We said the opposite side is not one of the arms. It's the side that is not one of the arms. So PR becomes our opposite side. And the adjacent side is one of the arms, but which is not the hypotenuse. So which means in this case, PQ or QP is our adjacent side. Now, I'll give you a few minutes to see if you can write the tan of theta. The tangent of theta. Okay, well, I know it was just seconds, not minutes. But here's my diagram. From the diagram, I've said the tangent of theta will be the opposite side, which is QR, over the adjacent side, which is PQ. So then now expressing it now as a ratio, it becomes the length of PR is 5 and the length of PQ is 12. And of course, we can express that as we can express that as a decimal number. Sorry, I'm just here trying to sort of get my calculator.
Patty, use your share screen option, and then you'll find your calculator on the share screen, if you've used it already.
Okay. Okay, share screen option.
Yeah, so you should be able to see on your share screen. It should, if your calculator is open, you should be able to find it that way.
No, I forgot to open it. That's why I was trying to say Alt tab so that it would appear.
I see.
But I think I did not open it. Let me just get out there and okay. Let me get back to my slideshow. Okay, that's where I was. Oh, this calculator is giving me hard times. Let me try again. Excuse me for a moment. Oh, this calculator doesn't want to come here now. I don't know what's happening with the calculator. But I done this before.
Patsy, can I jump in for you?
Yes, please.
Okay, I'm just going to share my calculator with everyone. So here it is. So what you want to do is you want to put 5 over 12, right?
Yes.
So we're just going to press 5.
5.
And then we can either use the fraction button or the divide, depending on what you want to do. And then we can say 12, and we say equals, and it's going to give us a fraction again. And then we just change it so that we get that answer over there. Okay. Patsy, you can reshare your screen.
Thank you.
No problem.
Okay. The same thing, you find that even here now, the next one that we have to do was to calculate the sine of theta divided by the cosine of theta. So what's important here is before we even work out what sine of theta divided by cos of theta is equal to, we've got to find what is the sine of theta. The sine of theta is given by the opposite side. There's theta is the opposite side divided by the hypotenuse. So it's 5 divided by 13. Cosine of theta, the cosine of theta is the adjacent side, which is 12 divided by 13. So which means now sine theta divided by cosine theta can be written as 5 over 13 divided by 12/13. And using your calculator, Tal, can you show us again how to do that?
Sure, no problem. Here we go. So what we want to do is say 5 over 12, right? Divided by, so you need to get out of your fraction, press your right arrow key, say divided by, and the next one was 13 over 12.
12 over
12
13.
over 13.
The other one was 5 over 13. It was 5 over 13.
Ah, my bad. We'll backspace it and say 13. And then the other one is 12 over 13. Yes?
Yes.
Awesome. And then again, we can just change and it will give us exactly the same answer again.
Thank you.
Back to you.
Yeah. As I've said here now, let's note it's very important that we look at things critically. You know, very interesting. When you look for the tangent of theta, it was 5/12, which went on to this. Now, when you look at the sine of theta divided by the cosine of theta, we still get 5/12, which is equal to 0.417. Now, one would say, is this always true for all values of theta? I'll leave it hanging for you to think about it. The next one, we're to find now sine squared theta plus cos squared theta. And you can see now, already we know the sine of theta. We've got it there, it's 5/13, but now we've got to square that. We know the cosine of theta, it's 12/13, but we've got to square that. If you square this, using your calculator, again, you just punch in the fraction, and then you go to the square, to this x squared key. It will give you 25/169. And if you square this, it gives you this. And if you add this, the answer you get is 1. Again, one would say, is it always true that when you say sine squared of an angle added to cosine squared of an angle, the answer is 1? Again, I'll leave that to you to sort of investigate and see the truth of it before we can make a conjecture. Right. Next activity. We are given the diagram. And the diagram here, we've got AB perpendicular to CD. This is the side, the line AB, line segment AB perpendicular to the line segment CD. And we've got our angle C is 50 degrees and our angle D is 40 degrees. Then we're told that here AB is 38 millimeters and you must find the length of CD. Wow. How do we find the length of CD? Well, we've got different options here. We know this angle, and what else do we know? We know the opposite side. So what we can work out the length of this adjacent side. Here again, we've got angle 50. We know the opposite side, but we don't know the adjacent side. We could try something and work out the length of the adjacent side. Then if you look at the length of CB added to the length of. So in my next slide here, I said, I redrew the same diagram and I said, if you want to find the length of CD, the length of CD will be the length of CB added to the length of BD. Now, do we know the length of CB? We know that the tangent of 50 degrees will be AB over CD. Now, that's where now I said that your knowledge of algebra will come handy, because we can substitute 38 for AP. You are given that AP is 38, and we can work out the tangent of 50 using a calculator. What you don't know is CP, which means now what we've got to do is we must try now and make CP the subject of the formula. Now, how do we do that? CP, we multiply both sides by CP so that on the left-hand side, CP and CP will cancel out, and then divide both sides by 1050 so that 1050 degrees and 1050 degrees will cancel out. Therefore, the length of our CP is given by AP divided by 1050 degrees. And now, if you go to a calculator, you'll find that, oh, in the same way, we can find the length of BD. Now, B over BD. And then again, changing subject to the formula, you'll find that our BD will be equal to AB over the tangent of 40 degrees. Now, what will be our CD? CD is the length of CP over 1040 degrees. P is 38 millimeters. So in both fractions, I put 38 in the place of AP. And then now using your calculator, this is the answer you'll get. Tal, could you do this one, please, for me, so that they see how you go about, again, working with ratios in your calculator?
Sure, Patty, no problem. Here's my calculator. So it's going to be, again, we're going to use the fraction button. So I'm just going to say fraction and then 38 over tan 50. Use your right arrow to get out of the fraction, plus, let's make a second fraction, 38 over tan 40, and equals, and there's your 77 millimeters.
Thanks, Tal, thanks. So
No worries.
calculator makes life easy. So I've just rounded off to the nearest whole number, and I've got 77 millimeters. It's just that because it's a small unit, it doesn't matter. The answer did not, the question did not say you must give the answer to how many decimal places. Now I'm trying now to move from triangles to doing the same thing now, but using the Cartesian plane. You could see that now the very same triangle that we had in the beginning, where we wanted to find the length of the distance of the island. I've just put the y-axis and the x-axis, and I've put the vertex of one of the triangles at the origin. Right, you can see that now, if you look at the island, the distance of the island, we can say the x always tells us how far something is from the y-axis. So how far is the island from the y-axis? It is x away from the y-axis. How far is it from the x-axis? It is y away from the x-axis. So which means this adjacent side here to the angle 40 degrees, we can call it, we can say its value is x, its length is x, because x tells us how far is the island from the y-axis. And then this distance here, which you don't know, we can call this one our, the length of this one will be given by the y coordinate. Now, I've actually tried to put this again now in a simple way where I've got right angled triangles. You can see that now if we look at this as right angled triangles, this was from my theta. This is the adjacent side, this is the opposite side, and I can find the length of the hypotenuse, which I labeled as R here. Now we said this triangle is right angled, isn't it? Now if it's right angled, I know this side, I know that other side. How do I find the third side? Now that's where now I said that now the theorem of Pythagoras comes in. So from the theorem of Pythagoras, we can work out what R is. We know that the value, the x squared plus the y squared should give us the R squared. Therefore, taking square roots, R will be equal to the square root of x squared plus y squared. Taking one, for instance, one of the points here at point P, I know that the value of my x is 3, and the value of my y is also 3. Now, I can say, if I say 3 squared, I've got 3 squared, that gives me 9, plus 3 squared, another 9. 9 plus 9 gives me 18. So which means my R for the bigger triangle is the square root of 18. And the square root of 18, now knowledge of your sets, we can always simplify sets. 18 is 9 multiplied by 2, and the square root of 9 is 3. So therefore, root 18 is the same thing as 3 root 2. That would be the length of my R for the bigger triangle. For the smaller triangle, what would be the length of my R? For the smaller triangle, again, I know that the x coordinate here is 2 and the y coordinate is also 2, which means it will be 2 squared, which gives me 4, plus 2 squared, which also gives me 4. If I add a 4 and a 4, what do I get? I get 8. And what is square root of 8? Well, which means r can be, I can say my r is equal to the square root of 8. But again, I can always simplify that root 8 to find what the actual length of r. 8 is 4 multiplied by 2, which means my r for the smaller triangle, which means the distance from here to t, will be given by 2 root 2. Okay, now if I want to find the sine of theta, how do I find the sine of theta? We said the sine of theta is given by the opposite. The opposite in this case, this vertical distance here is y, and the horizontal distance adjacent side is x. But the hypotenuse is always given by r. So which means I would say if I'm using the bigger triangle, what is the length of my opposite side? The length of my opposite side is 3. And what is the length of my r? Already I've said my r is 3 root, and that simplifies to 1 over root 2. But again, when working with sets, when we work with irrational numbers, we say if you give your answer with the denominator as a set, it's not yet simple. We want to simplify things in mathematics. How do we simplify this? We rationalize the denominator. We multiply the numerator and denominator by root 2. And in the end, we've got root 2 over 2. And that means, again, you must know that if you multiply root 2 by root 2, the answer you get will be equal to 2. But if you multiply 1 by root 2, you will get root 2. In the same way as if you multiply 1 by 3, you get 3. 1 by 5, you get 5. Now, let's say if they want us to find the value of theta, which is the angle. Now, you'd find that we've got a new function that we use in our calculator. Now, to find the angle theta, we know our sine theta. Our sine theta is root 2 over 2. So to find theta, we must look for the arcsine of root 2 over 2. Arcsine of root 2 over 2. Again, it's easy to see that this comes up to 45 degrees. But for the sake of those who have not used the calculator, please do this one for us.
Sure, Phatha. Here it is. So when you want to access the arcsine of something, you need to use your second function button on the calculator. So we just press second function first and then the sine button, and that will give us that little -1 in the top corner. And then we have, it's root 2 over 2, right?
Yes.
Root 2, and press down over 2. And you can either close your brackets or leave them as is. Either way it'll work. The only time you would need to close your brackets is if you're going to complete this with something else next to your arcsine. So there is your angle, 25.
45 degrees.
Sorry, 45.
Thanks for that. Right. So now you can see that using trig, we're not only able to find length of sides as we did in the other problems, but if we know the length of the sides, we can also find the size of the angle. And to find the size of the angle, if we know the sine, we use arcsine. If we know the cosine, we use arccos. And if we know the tangent, we use arctan of whatever the tangent was. There's another activity. This activity, again, just gives us some practice into what we've done there. For instance, now we're given a point B, and a B, if you took the line AB, the angle of inclination of our line AB to the x-axis is given by alpha. The coordinates at B the x coordinate is 2 and the y coordinate is 3. We said the y coordinate will give us how far the point is from the x-axis, which means from here down to here gives us, the length is 3. From here to across there, the length is 2. But now, do we know our r? We don't know our r. And the very first question says we must find the length of AP, which is our r. And then thereafter, once we know our r, we can always work out the sine of alpha, work out the cosine of alpha, and work out the tangent of alpha. How do you get the sine of alpha? To find the sine of alpha, we always take the y, which is the opposite, and divide by r, which is the hypotenuse. To find the cosine, we will take the adjacent, which is x, and divide by r. And to find the tangent, what will you do? We will take the opposite, which is y, and divide y by x. So now, looking at the solutions, you could see that our AP is equal to the square root of 2 squared plus the square root of 3 squared. This is our x squared and y squared. And you can see the square root of 2 squared is 4, and the 2 squared is 4, and 3 squared is 9. If you add 4 and 9, what we get here is root 13. It's very important that learners must know that this is not root 4 plus root 9. But we will look at that later on, because it's a common error that learners make, that they say root x plus y is the same thing as root x plus root y. Now the sine of alpha. Now we know our r. It's always to find the sine, you take the y coordinate, divide by r. The cosine of alpha should be the x coordinate, divide by r. And our tangent will be the y coordinate divided by the x coordinate. As easy as that. Now the beauty of this is that now you're not confined. Your angle could be any size. It could be acute, it could be obtuse, it could be reflex. As long as you know the coordinates, then you are able. So the beauty of defining these ratios using the Cartesian plane is that now we're not confined in terms of the angles. For instance, here there is in the diagram, O is at the origin, and the angle beta is obtuse. Now we must find the length of OM. In the same way, we know what our x coordinate is, we know what our r coordinate is. So now how do we find the length of OM? We are going to use Pythagoras. Assume that the length here, this height here is 2, and this length here is 3. But you can use the coordinates as they are. For instance, you could see here that what I've done here, I've just said length of OM will be, you take the -3, you square, and then you add your 2 squared. You square -3, you get 9. You square 2, you get 4. 9 plus 4, that gives you 13. So you can say that OM again is root 13. And then to find the cosine of beta. Now, how to find the cosine? The cosine is always given by the x coordinate divided by r. So since our x coordinate in this case is negative, so now the cosine of beta will be -3 over root 13. To find the sine of beta, now the y coordinate is positive. So which means now our sine will be 2 over root 13. Again, we can make our own thinking and think critical that, oh, if the y coordinate is positive, then the sine will always be positive. If the if the x coordinate is negative, then the cosine is negative. Try find other solutions and check if this is always true. And sometimes, you know, we do make conjectures and find that they don't always work, but take your time and check if it works for all of them. And now coming to the tangent of beta, you can see now it's the y coordinate divided by the x coordinate. But since again the x coordinate is negative, you can see that now the tangent of beta will be -2/3. It will be negative 2/3. Now we want to find beta. Now to find beta, we know the cosine of beta. Cosine of beta is negative 3 over root 13. And so we should look for the arc cosine of this. Now, this one is a bit tricky if you use a calculator. So I'm not going to get into the calculator, but later on you will see that what it gives you an acute angle. And then to find the actual size of the obtuse angle, you must subtract that acute angle from 180 degrees. And then in the end, we've got that 146,3 degrees. If you'd like, you could use the arc sine, because you know the sine is 2 over root 13. Even if you use the arc sine, it takes you to the same answer. With the arc sine, you will find that again, it will give you an option of either the angle is in the first quadrant or in the second quadrant. Again, you have, I've actually said the other way around. Here, our value of beta will be negative. So we add 208 to get this. Here, our value of beta will be positive, but acute. So we subtract it from 180 to get this. And then again, here for the tangent. For the tangent, generally, if you use a calculator, it will give you an angle in the fourth quadrant, which is a negative angle. So again, you take that angle and add it 280 degrees, and then you get 146. So you could use any of the three to find the answer. But take your time and give this a try and use your calculator. Practice and see what makes sense. Because anyway, it doesn't make sense to have an obtuse angle being 46 degrees. So if you get 46 degrees, then that means something. It's either what you have to do so that it becomes obtuse, you take 180, because it will give you the size of this angle here at this if you complete your triangle. But you're not interested in this angle. What you want is the angle here. Therefore, from 180 degrees, we subtract this angle and get this angle. Activity 6. Now we're about to finish. This one I've just given you so that you can always think back about the definition of the trig ratios. Now we're given here the sine of the angle x. The sine of angle x is root 3 over 2. And we're told that x is an acute angle. Why are we told that x is an acute angle? We've seen that the sine could be positive in the first quadrant, and it is also positive in the second quadrant. So even if your angle is obtuse, your sine will always be positive. So specifically here, they told us that x is an acute angle. And then you must find cosine x, find 10x, find the value of sine x divided by cos x, and ultimately work out what the value of x is. So it's more of reinforcing what we've done. But one thing that I want you to take note of is, if you are given that sine x is root 3 over 2, we've defined the sine as the opposite over the hypotenuse, which means we could present it as a triangle like this. If I've got my angle x, the opposite side to the angle x is root 3, and the hypotenuse is 2. Then of course I can always work out the third side. It's easy to work out the third side. This is a right angle triangle, so I could use Pythagoras to work out the third side, or again I could use the trig ratios to work out what the third side is. Now, if I'm using Cartesian coordinates, I know that I've got an angle that is x. And my r, because I know that the sine, if I define it using the Cartesian plane, it's given by the y coordinate over r, which is the distance of the point from the origin. So now I don't know the x1, which is a, but if I know the r and I know the y, it's always easy for me to work out the value of a using the theorem of Pythagoras. This generally pitches up even at grade 12, where you're given something like this. So always once you're given a ratio and it's given as a fraction, think of how we define it. If it was a cosine and you've got root 3 over 2, then you would know that root 3 is the adjacent side and 2 is the hypotenuse. If it was the tangent and you had root 3 over 2, then you'd know that the opposite side is √2, is √3, and the adjacent side is 2. But in this case, we're given that sine x is √3/2. So using our knowledge, we can always work out. So now let's solve it. From this triangle, which is easy to work, I can work out the adjacent side, or the value of the x coordinate. The adjacent side will be, and now I take the square of the hypotenuse and subtract the square of the other side. So I've got 2 squared minus √3 squared. From a calculator, if you square your 2, it will become 4. And if you square this, it becomes 3. And then 4 minus 3 will give you √1. And in the end, the answer will become 1. I'm not giving Tal a chance to do this one for us because we still have others that will need a calculator more than this one. So now we can find now our cosine. We know that the adjacent side is 1. So what is the cosine? Adjacent side over the hypotenuse. What is the tangent? The tangent of x will be opposite side over the adjacent side. And now you can see that now you've got √3/1. We can just, in a simple way, write it as √3. But it helps if we're given that 10x is √3, we would know that the opposite side is √3. Therefore, the adjacent side should be 1 because there's nothing at the bottom. At the bottom, we've got 1. There's nothing written, which means if there's nothing written there, which means the denominator is equal to 1. Wow. Again, if you take sine x, divide by cos x. Wow. I've got this divided by that, I got √3. We did come across something like this before, and I asked, is 10x always the same thing as sine x over cos x? Let's think about it. It's bringing something. You can play around, assign different values to x, and work out, try to find out if your calculator gives the same answer when you look for 10x and when you look for sine x over cos x. Now, finding the value of x, of course, I've used all of them. You could use the arc sine. The arc sine of, we know our sine is, we given the sine is √3/2. So we could look for the arc sine of √3/2. Or we've found our cosine, which is half. So we could look for the arc cosine of half. Or else we could look for the arc tangent of √3. All of them will, if you press your calculator, they all give us the same value, and the size of angle x is equal to 60 degrees. The value of the angle x is 60 degrees. Wow, I remember this one was exactly in the paper. Now we're getting now into solving problems now, which is what maths is all about. 2 trees. Well, we've called the other 3 AB, and the other one we've called CD, are planted on the flat ground, which means this ground here, this is level. The angle of elevation of their tops from a point X on the ground is 40 degrees. Well, it would be, to elevate means to lift, which means if you're up there and you look up, you elevate your eyes, the angle with which you elevate from the point X is 40 degrees, as we've got the angle there, 40 degrees. And they say the horizontal distance between X and the shorter tree, this distance here is 8 meters. And they say the distance between the top of the shorter tree and the top of the shorter tree is 20 meters. Now they want us to find the height of the taller tree. Now, from the given information, what do we need in order for us to find the height of the taller tree? Wow, that needs a bit of thinking. I've redrawn the diagram and I say, we resolve the diagram into triangles. As you can see, we could say this is our first triangle. In this triangle, which side is opposite 40 degrees? It will be CD. Which side is adjacent? It will be DX. Which side is the hypotenuse, it will be CX. Now we know the angle, we know the adjacent side. We can find CX. What is CX? CX is the hypotenuse. So already I've specified what you know in the triangles. What you know in the triangles, in this one, we know this angle and you know the adjacent side. But we don't know CX, we don't know the height of the tree. But we really need the height of the tree, because if we know the angle and we know that hypotenuse, how far this is, we can always work out, because in trig, we only need three things. We either need an angle and a side, or we need two sides, or we need an angle and a side. That's all we need. So now, what should we calculate? For the first one, it's better if we start by calculating CX, because if we know CX, we'll be able to find the length of AX. That's the reason. If we know CX, we can find the length of AC. Now, again, as I said, your algebra should tell you that if I want to use this one, use this angle and use this, which ratio uses an angle, adjacent side, and hypotenuse? Now, I should use the cosine. If I'm looking for the cosine of 40 degrees, it will be the adjacent side, 8 meters, over CX, which is the hypotenuse. Therefore, changing the subjective of the formula, my CX is equal to 8 meters divided by the cosine of 40 degrees. And if I work out this from my calculator, the answer I get is 10 meters, 10,4 meters. Now I know that CX is 10,4 meters. How long is my AX? My AX now should be 20 meters plus 10,4 meters. Now, what I'm going to say now is using the sine of 40 will be opposite over the hypotenuse, which is my AX. So I can say the sine of 40 degrees is height of the taller tree divided by AX. Therefore, changing subject of the formula again, the height of the tree is equal to, I just multiplied both sides by AX, and this side AX and AX cancel out. So this side I've got AX sine 40 degrees. So the height of the tree is AX sine 40 degrees. And my AX is equal to 20 meters plus 10,4 meters, which is 30,4 meters multiplied by sine 40 degrees. And I end up finding that the height of the tree is 19,5 meters. Well, I know that probably I'm doing this quite quickly, but as Tal has promised that you'll get this recorded lesson as well as the slides. Take a time again and think about how you can solve a problem similar to this one. Now, this is the last activity of the day. Again, I will take you back to the calculator. Now, I want us to solve a real problem. Now, they say now, we know the distance between point A and point C. We know the angle. If you want to look at the island from point A, and you know the angle if you look at the island from point C. Now, ours is to find how far is the island from the coastline. It's the same thing. You know, for instance, what engineers would do if they want to determine something about a star. They would set up at one point and then set up at the other point and look at the star. Or else they would look at the star when it's up there, leave it for a few minutes, and then look at it when it's at another point, and then they can make some dotted triangle and then work out. It might be complicated trigonometry, but here we're going to try and be as simple as possible. Right. Number one, I said, what is the size of angle ADC? The size angle ADC. Now, if I look at the triangle ADC, this angle here is 40. This one is 50. This one, I don't know. But what do I know about? I said you should know properties of your triangles. What do you know about the angles of a triangle? The sum of the interior angles of a triangle is 180 degrees. So then now, we can say the size of that angle there will be 90. 90 plus, if you add these two, you get 90. So that one must also be 90. Now, what type of triangle is ACD? It's fine. ACD, we can say now that's a right-angled triangle. That might help us because with right-angled triangles, if we know some sides and the angle, we can always work out. For instance, you can say in this right-angled triangle, we know this side is 50 meters, we know this angle is 50. Or we know this side is 50 meters, we know this angle is 40. Then we can work out what the other sides are. Wow, let's see if we can work it out. For instance, we say, one option is we can say, all right, if we say AB is equal to X, what is the length of BC? Well, when we speak of AB equal to X, let me say, for instance, if X is equal to 10, so which means AB is equal to 10, what will be the length of BC? Should be 50 minus 10, which is 40. If I say my X is equal to 30, so which means my AB is 30. What is the length of BC? 50 minus 30, which is equal to 20. So now we can say if AB is equal to X, if AB is equal to X, AB is equal to X, therefore BC should be 50 minus X. I don't care what X is. If X is 10, this is 10, this one will be 50 minus 10, 40. If X is 20, this one will be 50 minus 20, which is 30. But that's what I know is that if I know the other one, I can always work out the other side. Now I can say, what is the tangent of 40 degrees? Tangent of 40 degrees will be this side, which is BD, divided by AB. And my AB, I know, is equal to X. Now, changing the subject of the formula there, I can work out what BD is equal to. Therefore, my BD is equal to X multiplied by 10, 40 degrees. Doesn't matter what X is equal to. 1050. Now looking at this other triangle here, at 50, this is the opposite side, and this is the adjacent side. My opposite side is BD. My adjacent side is 50 minus X. Therefore, from this, what can I come up with? This. Then BD, changing subject of the formula, BD is 50 minus X multiplied by 1050 degrees. What does that mean? This means this is the length of this is the length of BD. This is also the length of BD. So what it tells me is that this X 1040 degrees must be the same length as 50 minus X multiplied by 1050 degrees. Now it's using that A is equal to B, at the same time A is equal to C. If A is equal to B, at the same time A is equal to C, therefore B is equal to C. So now I've got X 1040 degrees is equal to 50 minus X multiplied by tangent of 50 degrees. Now your knowledge of algebra. This side, I've got a binomial and I've got a monomial outside. So what am I going to do? Multiply what is inside by what is outside. So now I've got something like that. The left-hand side is as it was, X 1040 degrees is equal to 50 multiplied by 1050. I've got 1050 degrees. Minus negative X multiplied by 1050, it's minus X 1050 degrees. Now, what have I done? I've taken this to the other side, or I've added X 1050 on both sides. X 1050 this side and plus X 1050 gave me 0. And then in the end, what have I done? I've taken out X as the common factor. Now I've got X into 1040 degrees, which is X times 1040 plus X into plus, if you say X times 50 degrees, which was that, I've taken out X, I've got 1050 degrees. This is equal to 50 multiplied by tangent of 50 degrees. Making X the subject of the formula. I've divided both sides by 1040 plus 1050. So I've got 50, 1050 degrees over 1040 degrees plus 1050 degrees. And I got the answer here. My x is 29.3 meters. Could you verify this for me, Tal?
Sure, Phatha, no problem. Let's do it on the calculator quickly. So we had 50 tan 50 over tan 40 plus tan 50, right?
Good.
Okay, and then as easy as that, equals 29.34, etc., etc.
Thank you. Thank you.
No problem.
But here, the question was not, we're not looking for x, because it said x is the length of AB. X is the length of AB. What we want to find here is how far is the island from the coastline, isn't it? Then what you have to do now is take this 29.3 meters, substitute there in place of x, and multiply that by 1040. So what does that give us? BT is equal to 29.3 multiplied by the tangent of 40 degrees, and the distance you get, how far is the island, is 24.6 meters. Wow, this is wonderful. Somebody said that this tells us that you can know how wide a river is without crossing the river. A second option. The second option, just to share with you, is one, we could do it like this. The size of angle D, we've agreed that it is 90 degrees because from the sum. Now, what to say now, if we put our AD, put this side equal to X. We know this side here, AC is equal to 50. This one is X. We can work out how long that one is using Pythagoras. This one is X, this one is 50. From Pythagoras, how do you find that side? It's square root of the square of the hypotenuse minus the square of the other side. We've done that in the other examples. So we can say from Pythagoras, our CD, the length of CD will be the square root of 50 squared minus x squared. This is 50 squared hypotenuse, and this is 80 is x squared. Then now we can use that, using the fact that we know the length of these sides. From the sine of 40 degrees, sine of 40 degrees will be BD over the hypotenuse, which is x. Therefore, BD is x sine 40 degrees. Sine of 50, now we on this side, sine of 50. Sine of 50 will be BD over this side, and this side said it is the square root of 50 squared minus x squared. So you can see there. Therefore, from that, we've got BD is equal to this. Again, like we did with the other one, we've got BD is x sine 40 degrees, and here we've got BD is this multiplied by sine 50 degrees. Now we can equate x sine 40 degrees and this root 50 minus x squared multiplied by sine 50, right? In the next one, I say from the previous slide, BD is equal to x sine 40 degrees. At the same time, our BD is equal to the square root of this multiplied by 50 degrees. Therefore, we can equate this. X sine 40 degrees is equal to the square root of this multiplied by the sine of 50 degrees. Now we've got an equation that has got a root sign. We've done equations in algebra. That's why I said that your knowledge of algebra will work. Generally, if you've got a root sign, how to remove the root sign? We square both sides. So squaring both sides, what do we have? If you square this side, x times x is x squared. Sine 40 degrees times sine 40 degrees, that's sine squared 40 degrees. You square this, it becomes, it's like you said, root 3 times root 3 will be equal to 3. Root x times root x will be equal to x. Root 50 squared minus x squared multiplied by root 50 squared minus x squared, it will give us 50 squared minus x squared. And then if you square this part here, you've got sine squared 50 degrees. Now it's just mathematics now of solving equations. What have I done here now again? The same thing. What is inside the bracket has been multiplied by what is outside the bracket. This multiplied by that, you've got 50 squared sine squared 50. This multiplied by that, you've got minus x squared sine 50. What have I done? This now appears on the left-hand side. So you know that generally we say that if this comes to this side, it becomes positive. So now I've got this plus this is equal to what is left on the right-hand side. Now coming down, this one is interesting because what you see now, I've got sine squared 40 degrees plus sine squared 50 degrees. Well, it's fine. You can check what this works out to using your calculator. But I won't do that now. But then in the end, what do? I want to solve for x. So I must divide both sides by sine squared plus sine squared 40 plus sine squared 50. This takes me to something like this. My x squared is equal to 50 squared sine squared 50 degrees divided by that. Then now what do? I'm not looking for x squared, I'm looking for x. Now what do I do to find x? Take root on both sides. Square root of x should be the same as the square root of the fraction on the right-hand side. Well, unfortunately, my typing here is bad. This should not be as long as it is. It should end up before the equal sign. That's why this was an error. But again, could you do this one for us, Tal, so that we see if you agree with the answer that I've got here?
Sure, Phatha, definitely. This is quite a nice one to do on the calculator. So what we've got is 50 squared, which we're just going to square, and then we've got sine squared 50, right? So on the calculator, you first need to do the sine 50, and then you need to square it. Okay, so just make note of that. And then we've got sine 40, and that is all squared, plus sine 50, and that is all squared. Because remember, we're squaring the answer of sine 50 and not just the sine. Okay, that's the reason that it's done that way. And, oh my goodness, what have I done? Oh, we need the square root. Let me just square root the answer. And there it is for you. Okay.
Or else I think you would have started by pressing the root and then put the fraction under the root. But
yes, that is true. But just in case, you can do it both ways. So, you know, for silly people like me.
Okay, so you can see we've got 38,3, which is our x. Again, you said you're not looking for x. What are we looking for? We're looking for the length of BD. So now you'll find that now we said BD is x multiplied by sine 40 degrees. So now what does it say here now? There's my BD. X multiplied by sine 40 degrees gives me 38,3 multiplied by sine, and the answer I get is 24,6. I think it's the same answer we got using a different method in the other one. So just showing that sometimes it's very important in mathematics, you know, that there's no one way of solving a problem. I just showed that these are the two ways of how we get the answer that I've used. And I've tried here to work within the knowledge of trigonometry that is appropriate for grade 10. Otherwise, there are other shortcuts that when you get to higher grades, you can always look into. For instance, some people would know that if you take sine squared plus cos squared, this becomes 1. So you could have had x squared is this multiplied by that. And you could just have gone to say, oh, my x squared is 50 multiplied by sine 50 degrees. And it would give you the same answer, which is 24,6 meters. And I think this was the problem that I wanted to say, that you see the fun of knowledge of trig, that with trig, we can get distances without really actually measuring them. But if we know a few things, then we can always calculate the other distances. So in concluding, I said I just found this interesting abstract in Google. Maths is needed at every step of life, and you cannot live without it. It is a subject that is applied to every field and profession. It tells us how things work and also allows us to predict certain things, which is how we have progressed so much in life. Maths has made our lives easier and uncomplicated. Without maths, you've got problems, and no solutions. Thank you.
Thank you, Phatha. That was awesome. We really enjoyed it. For those of you who are here, thanks so much for joining us. I hope you found it useful. What I will do tomorrow is send out a link of this recording. So with that in mind, those who are watching the recordings, please subscribe to the YouTube video, as well as follow our Zapper link to donate to the Future Fund. So this is all done in aid of our Future Fund 2.0. What we are doing is trying to raise funds for calculators for students who cannot afford their own calculators. And as you've all seen, this year has been absolutely crazy. There are a lot of people who've lost their jobs and parents who cannot provide a calculator for their kids. So we really want to help them out, and that is the whole reason we've partnered with Casme for these workshops, is to make sure that these kids get calculators. So tomorrow, please look out for that Zapper link, and if you are watching the YouTube video, the Zapper link will be in the bio underneath this video. All right, I'm going to stop recording now. Thanks for watching.